Hey guys, welcome to Tips and Tricks. This is Viren here.
And my CCNA number is 122210109, and this is my video number 4. So once again, just go through these ground rules or a few points. You can just do a pause and go through these. I'm gonna move on to the next slide. So these are the topics that we will cover. What is Ethernet, and we will understand what is CSMACD. That's the principle on which Ethernet works. Okay, so before getting into this, I just want to bring up the scratch pad. So as you see here, Robert Metcalfe was trying to connect his computer to a printer, and this was in 1973. And while doing this, he invented and he designed Ethernet. So to get this connectivity, this was the protocol that he came up with, the Ethernet. Alright, and remember that Ethernet is a local area technology. Just to brief you on that once again. If you remember, we saw local area networks and the WAN networks in the earlier videos. So let's say that you have a lot of computers in your office, and you guys need to pass on information and talk to each other. The protocol that is used here, that is Ethernet, which is a LAN or a local area network protocol. Now let's say you are going ahead and requesting google.com, which is actually outside your. Now you're getting connected to the internet. There should be a router here. The moment you go outside this path, so this is a WAN link. Why do we call it as a WAN link? Because you are now getting into the wide area network, because you're getting connected to the internet. So this will be a service provider, whether it's T-Systems or whatever provider your company is using, the ISP, which is getting connectivity to the internet. Once you go there, there are WAN protocols. So remember, Ethernet is a LAN protocol or a LAN networking technology which works within this area. Alright, okay, let's move on to the slides. So as I said, Bob Metcalfe invented or designed the Ethernet in 1973. This was over a single cable. We already saw that. This was over a single cable, and any device connecting to this cable, to this single cable, could look into the communication or get into the transmission or see the data that's passing on from here. So let's say that from computer A it was going to the printer P. Now let's say I connect another computer here, or a device. So this device could see what's going on in this cable. That's what it says. Now these are the features of Ethernet. As I already told you, it's a LAN technology, local area technology, with networks traditionally operating within a single building or adjacent building. So basically, this was old times, but nowadays Ethernet has evolved and a lot of design changes have done. So now you can connect from one building to the other also, which has quite a distance rather than being an adjacent building. Again, in the last point it says, the slide says, in networking the term protocol refers to the set of rules, or basically that's what I said in my earlier videos also, that protocol is nothing but a set of instructions or language that makes devices or computers talk. And Ethernet is one such protocol or language. So Ethernet understands frames, just like we speak to each other via language. So let's say now, whatever information that I'm giving you on the slide, there are a couple of sentences that I've made here which make sense to you. So similarly, Ethernet deals in frames. And why am I specifically emphasizing and talking about frames? again and again is, if you remember in the earlier video we talked about the OSI model. Now in OSI model, if you remember, we had 7 layers and each layer had its own work to do, and each layer had also, so this was 1 2 3 4 5 6 7. So if you remember, the switches, or simply the layer 2 switches, layer 3 switches work at network layer, but the data link layer, this is where your switches and bridges, oh, I'm sorry, let me just draw that again, it's not coming up. So 1 2 3 4 5 6 7. So the bridges and switches act at this layer, bridges and switches, and bridges and switches look at what part to find the destination? They look at the MAC address, medium access control, so which is the hardware address on each machine, and we will also look into what is a MAC address in the next video. But for now, just remember the NIC card that is in your PC, the network interface card, which helps you to connect to all other PCs, you know, whether it's internet or whether it's in normal connectivity. So let's say that you have this office where you have a lot of computers. So even before getting this connectivity to each other, forget about the internet. Within this connectivity also you will need the NIC card in each PC, the network interface card, which helps you to talk to each other. So the bridges and switches work on this MAC address, which is unique for every NIC card. In fact, we have a MAC address for the phones, the hardware phones, the hard phones that you see in your offices like Avaya phones or Cisco phones, even they have a MAC address. This MAC address is unique for every device on this planet, and you'll see how it is unique. We'll look at that in the next video. For now, just remember that the bridges and switches work at the layer 2 and the routers work at layer 3, which is network layer. So if you remember, at the network layer the data is called packets, and at the second layer it is called as frames. So let's say that you have a LAN here, a lot of computers here, you have ISP connectivity, and you have another office in another city. So the packets travel here. So when you send a data from A system here and you're trying to send it to B over this office in the other city, the packets come here, the packets are thrown off, and inside there are frames. Now it is these frames that the Ethernet looks at and then gives the data exactly to the appropriate machine B with whatever bunch of machines we have here. So now you know why Ethernet is a LAN technology, because Ethernet cannot travel over the ISP link, where the packets are traveling. And that's what exactly what it says here, that we deal in frames when it comes to Ethernet. And Ethernet follows a principle called as CSMACD. This is the main principle. And let's see what is CSMACD. And the other point, okay, I don't want to miss this point. Ethernet basically follows a bus topology. So what is that? Let me just bring up that. So basically, bus topology is something like you have a computer A here, then you have B, you have C, you have D, you have E. So basically what's happening is, if you see here, there's one backbone. There's a single backbone and the structure is looking more like a bus. So this is called a bus topology. This is the kind of arrangement. There are other technologies like IBM Token Ring, which somewhat works like this. that is also again a LAN technology, just like Ethernet, but it works in a round robin fashion. So you have systems like these. So you have A, B, C, D. Now round robin doesn't mean the systems are connected in round robin. The idea is just to show you. So basically A will give an information to B, and then it will give to C and D. So let's say A gives it to B and then to C. Now before going to D, let's say B wants some data once again. That communication will happen only, A will first check with D. If D doesn't want to communicate, only after that it will come back to B. Whereas if you see in Ethernet, we have a backbone where everybody is connected here on this backbone, which is more like a bus structure, and that's why Ethernet follows bus topology. Okay, so Ethernet follows something called a CSMACD, that is carrier sense multiple access collision detection. So what is this principle? This CSMACD principle, what is the importance of it? So for this, let me just bring up the scratchpad once again and real quick show you something. So let's first understand it by an example. So let's say that there is a round table, a dinner table, and you have people sitting here, A, B, C, D. So let's say A wants to talk to D, but again at the same time B wants to talk to D, or anything. It can be, let's say A wants to talk to C and B wants to talk to D. So what happens is, the moment A and B both will speak, they will see that, oh, B is wanting to talk, or B will see that A is wanting to talk. So they will stop. They will not communicate. And then after a while, maybe they will try to communicate once again. And again in this attempt, they might again, get into the same situation, and they'll keep trying. Excuse me. So what happens is, they'll keep quiet, and after some time, when A or B sees that, okay, the other person doesn't want to talk, then they will do the communication. After that, A will do the communication. This is what the whole principle is about. So this is how it is. So what we did in the earlier example was, there were multiple people, so the multiple access was there. But again, the CSMA, carrier sense multiple access. So even though multiple access was there, A and B could sense each other. They could see each other as who is trying to communicate, then they stop and then they try to communicate again. And the last part of it is CD, which stands for collision detection. So the collision was getting detected the moment they were trying to speak to each other. They would see that, oh, B is trying to speak, so I'll keep quiet, and A is also keeping quiet. That's what Ethernet does. So let's say A, this is a computer here, it's connected in a bus topology, because that's what Ethernet follows. We have a B, we have C computer here, and D, and let's say we have a E. So what happens is, if you can see that all of them are connected to a single backbone or a single segment, and exactly that's what's happening here. So when A wants to use this segment to go to B or C or D or whatever, so let's say A wants to go to D, so it will use this wire. At the same time, B wants to go to C. So the moment they see that the wire is not free, okay, they will not communicate, they will not transmit. Even if they transmit, they will collide. That's what's going to happen. But let's assume that they try to transmit and they don't do it because the wire is not free, so they'll stay back and they'll try to do it again. But let's say if this delay that this delay that they keep quiet is for 2 seconds all the time, then they'll they'll stop every 2 seconds, because they'll sense that backbone is not free, and they'll never transmit. So to overcome this, In this principle, the delay is random. So let's say the first time the delay was 2 seconds or 1 second. I'm just saying 1 or 2 seconds. It has to be microseconds in real time. And then the next delay would be something else. So then at least somebody would be able to speak. So I hope this this makes sense. So that's what is given in the slide here, that Ethernet nodes also listen to the medium, that is they listen to the wire where they transmit, to ensure that they are the only station where they are transmitting. They want the wire to be free. If the station hears their own transmission is coming garbled, let's say if A knows that it's information, it's hearing some garbled sound, it knows that okay, it has collided. That means somebody else was also trying to speak on the same segment. The last one, a single Ethernet segment is called a collision domain. Now this is called a collision domain, this segment. So the other thing that we can see here is, so let's say A to E, and there was another way to go to E. So there are two ways A can go to E, through this and this. So now it has two collision domains. This is a collision domain and this is a collision domain. But in this case, if you see, there is only a single segment. So everybody who's using the wire, this is the place where they will collide. So that is why it is called a single collision domain. And in the same place, let's say if A had another way here, this would be the second collision domain between A and E. Okay. So when the stations detect a collision, when the stations, they are talking about the PCs or the devices or the computers, they cease transmission, wait a random amount of time and attempt to transmit again. That's what I said. The random pause and retry is an important part of this protocol, that is Ethernet. So this CSMACD principle, it follows the random delay. If they and that's what the 3 points explains. Let me just go to the next slide. Okay, that's it. I guess that's about it. We have covered CSMACD. If you want to, you can go ahead and search on the Google for it, but that's what it is. I mean, this is what CSMACD is all about. This is the principle that Ethernet follows while doing transmissions. So I hope this was clear, and again, if it is not, go through this video again. If you have any doubts about the topics covered in this, feel free to give your comments and feedback, and subscribe to this channel. There are a lot of other videos coming in, and stay tuned. Thank you, everybody.